Volcanoes are large fissures in the crust of the Earth or another celestial body prone to ejecting lava, gas, and ash from a subterranean magma chamber. While we're naturally most familiar with what happens on Earth, there's also volcanic activity on other planets like Venus and Mars. The largest mountain in the entire solar system is also a volcano, Olympus Mons on Mars. Elsewhere, there are cryovolcanoes which eject large quantities of ice and water rather than lava. They occur on Saturn's Enceladus, for example, and were once present on the asteroid belt dwarf planet Ceres. Back on Earth, though, and the vast majority of volcanic eruptions actually aren't big, fiery explosions, and that's because 80% of eruptions happen underwater. Here, the lava doesn't pose much of a direct threat to us, but these monumental events are still responsible for forming new sections of the Earth's crust, and eventually, islands. Hawaii and the Canary Islands, among others, are archipelagos formed by millions of years of volcanic activity. It's the same process, though, with the same reactions that are happening in both volcanoes on the surface and those at the bottom of the sea. Volcanoes form either on plate boundaries, often destructive plate boundaries as one tectonic plate is forced underneath the other at a subduction zone, or over hotspots, which are holes in the Earth's crust where lava can flow. Magma builds up beneath the crust from the mantle, and pressure begins to increase as more and more magma flows into the magma chamber underneath the volcano itself. Inevitably, the pressure is one day released in an eruption, with destructive lava bursting and oozing from the primary vent or from one or more secondary vents. An eruption is often accompanied by earthquakes, which can then trigger tsunamis in the case of underwater volcanoes, or, depending on the climate, avalanches or powerful, devastating mudslides called lahars. Those living near to a volcano know that in the weeks or months preceding an eruption, there can also be small earthquakes as magma moves around in the magma chamber below. Monitoring these smaller, seismic events is one of the best hints volcanologists can get that a volcano might be about to erupt. It can work the other way around, though, as violent but separate earthquakes have been known to cause volcanic eruptions that may not have happened otherwise. The explosivity of any eruption depends on the type of volcano and eruption itself. The two main types are shield volcanoes and stratovolcanoes, sometimes called cone volcanoes. Shield volcanoes have gentler slopes and produce thinner, runnier lava, while stratovolcanoes usually appear taller and are liable to erupt much more aggressively. Most of the famous and dangerous sites like Mount St. Helens, Vesuvius, Etna, and Krakatoa are stratovolcanoes. But this isn't to say shield types aren't dangerous as well. Any kind of lava stream is going to damage anything in its path, and the most active volcano in the world, Kilauea in Hawaii, is actually a shield volcano. Kilauea's most recent eruption technically took some 35 years to complete, inflicting damage across Hawaii's Big Island for all that time until, in 2018, an especially explosive and destructive stage finally brought it to a close. On average, however, stratovolcanoes are still more destructive and deadlier overall. Take the infamous 1980 eruption of Mount St. Helens in the Pacific Northwest. It was so violent that new fissures and craters were formed from lateral explosions, as a large bulge of magma that had been steadily growing inside eventually burst in all directions. Almost a century earlier, and the 1883 eruption of Krakatoa was so powerful it broke the original island apart and produced what's still considered the loudest sound ever heard on Earth. Meanwhile, Vesuvius is today not only an active volcano, but it also hosts the most densely populated volcanic region in the world. If it were to erupt again, there would be millions of lives at risk in Italy and across the Mediterranean. It's no wonder then that volcanoes are a massive field of study, with plenty of researchers getting up close to learn more about them, with the hope of accurately predicting when they might next erupt. It's thanks to the constant monitoring of Kilauea that many Hawaiians have been kept safe, while the Yellowstone supervolcano, arguably the most famous volcano in the world, is always under study and observation. In some parts of the world, including Iceland, extinct volcanoes can be explored and toured without any danger. But there are a brave few who venture inside the craters of active volcanoes in the name of science. Dr. Chiara Maria Petrone of London's Natural History Museum is a scientist who explores volcanic tunnels, hunting various rock types which help us understand what she calls the psychology of a volcano, or how it works inside. Then there are some of those like Ulla Lohmann, a German photographer who travels into volcanoes to take spectacular photos of rare phenomena like lava lakes, all to help improve our understanding of them. Lava lakes are perhaps the best example we have to show us what a volcano might truly look like during an eruption. They're like surface windows into the Earth's mantle, full of burning, bubbling lava that's itching to burst free. There are less than 20 confirmed lava lakes in the world, and they're not permanent, but they are the closest we can get to seeing the inside of an erupting volcano and living to tell the tale. Some particularly famous lava lakes, at least in volcanology circles, were in the Marum and Bembo craters on Ambrium, a volcanic field in the South Pacific Ocean, but both disappeared after an eruption in late 2018. For a while, though, they were stunning attractions to entice the bravest and most determined of explorers, though actually reaching them demanded a lot of specialist know-how and equipment. Say you were actually inside a volcano at the moment it erupts. The power would be inescapable. You'd experience endless tremors in the walls and rocks around you as the eruption began, and you'd also be subjected to boiling hot toxic gas in the air, superheated by the rising lava. But neither the tremors, nor the gas, nor the lava in themselves are the most dangerous parts of a volcanic eruption in its entirety. The most dangerous part is what happens when all those things mix together. Pyroclastic flows are almost always the deadliest aspect of any eruption, and they happen almost entirely outside the volcano itself. A mixture of volcanic matter, or tephra, which includes ash, rock, and gas, is ejected from the volcano in a devastating gray and ominous cloud, creating the big plume of smoke that you see around an eruption in the distance. More than just choking anyone caught within it, though the rock and ash can exceed temperatures of 1,500 degrees Fahrenheit, while the gas can be as hot as 1,800 degrees Fahrenheit. And if you're close enough to feel the heat, then it's already too late. On average, a pyroclastic flow travels around 60 miles per hour, but at their fastest they've been known to move at 450 miles per hour, only a little slower than a commercial airplane. But even if you were in a plane, the flow is often blasted high enough into the air that you might still not escape it. During the historic eruption of Vesuvius in the year 79 AD, it was the pyroclastic flow that froze the people of Pompeii as they fled. All across the Earth's crust, for all of our planet's history, pressure has continually built and released in seismic spikes. But sometimes the results of this geological necessity are spectacular and deadly. And that's what happens inside an erupting volcano.